Okay? So this is page 9. And it says use your calculator for the first 2 problems. It says use your calculator using Gauss-Jordan reduction. Now, what does that mean? If the directions say Gauss-Jordan reduction on your calculator, what kind of matrix are we starting with? What? We're starting with the augmented matrix, which is your x, y's, and z's, and your number. This is Gauss-Jordan reduction, which is going to be the RREF, reduced row echelon form. That's what we're shooting for. All right, making sure we copied everything right. Okay. Then I'm going to put it in. So here I go. How do we get it in there? Second matrix, edit. 3 by 4, because those are the dimensions of this guy. And then second quit, and right back into second matrix. Over to math, down to RREF. Matrix A. Uh-oh. I do not like the looks of this. Did you get some decimals? All right, let's math bracket. I still don't like the looks of it. Did you get, tell me if I'm on the right track before I got all this written down. This look like what you got? Okay, now this is not what I want to have happen. However, this happened on the last review sheet, and it's happened again. So chances are it's going to happen on your test with one problem or another. Something like this is going to happen. Ideally, when we RREF, reduced row echelon form, we get a matrix that looks like this. This is what we want to have happen, because that tells me that x is 3, y is 4, and z is 5. That's not what this says. That's not what this says. What do I do with this? Z equals z. I don't have any idea what z is, but I know 0 of them equals 0, which means z could be anything. So to depict that z could be anything, we say z equals z. Now, if we back up a row, what does that row say? Now remember, these columns are variables. So what does this say? Y minus 5/3 z equals 13/3. Now I want to know what y equals. That's my job. Find x equals y equals z equals. So y is going to equal 13/3 plus 5/3 z. And then the top row says x plus 2/3 z equals 8/3. So x equals 8/3 minus 2/3 z. Now, this is a mess. It's a mess. So we need to organize it. So remember how we do that? How do we write our answer to get things organized? What do? We say here's my variables. This is x, y, and z. And each one has 2 parts, a regular number and a z. So the regular number for x is 8/3, and the z is negative 2/3. For y, the regular number is 13/3, and the z is 5/3.
There's negative, and this goes positive, negative.
there's no number, at least not that we can see, it's a 0, and 1Z. Now, that's how we handle it when this happens. This is what happens sometimes. Hopefully, this is what will happen. Because if this happened, your answer would just be 3, 4, 5. That would be your answer. Okay. All right, next, number 2. Solve using the inverse method. Now, we're still going to do it on our calculator, but now we're doing the inverse method. Now, remember, this is what you need to remember. You need to remember Gauss-Jordan reduction. You put in your augmented matrix and RREF it. That's what we do for Gauss-Jordan reduction. For the inverse method, we put in 2 matrices. We put in a matrix for the coefficients. Okay, this is a bigger one. Just the coefficients. So A, B, C, and D, that's all. Putting in zeros if something's missing. So 1, 1, 1, 10, 1, 1, 1, 1. 2, negative 1, 1, 0. 1, negative 2, 1, negative 1, and 1, 1, negative 2, negative 3. So hopefully I got all those copied right. So that's the matrix I'm going to put into my calculator and call A. Then B is going to be all the other numbers in the problem. So B is going to be 10, 7, negative 1, and 0. So I'm going to have to put in 2 matrices this time. Second matrix, edit. What are the dimensions of matrix A? Thank you. So once I get matrix A in, I'll second quit, then back in, second matrix, over to edit. But now I'm putting this in as B, so after you go over to edit, you gotta go down to B. What are his dimensions? 4 by 1. Now, after you get both of those in, the operation you need to do when you're using the inverse method is simply this. A inverse, the inverse of the coefficients, times B. So we're going to go a second quit out of there. Go back to second matrix, hit enter, that's A. Now put your little inverse on it, that's your little negative 1, it's right there, it's a button, X to the negative first, times second matrix, click down to B. Oh, cool. This one worked out. What did you come up with?
4D2.
Yep. Which you may certainly leave that way, or you can write horizontally. This means X is 4, Y is 3, Z is 2, or whatever, A, B, C, and D, whatever. X, A is 4, B is 3, and so on. All right, so both of those problems, those are the only calculator problems. Everything else is no calculator. But both of those, you need to know what to do, because it's just going to say solve using Gauss-Jordan. So you need to know that means I set up my augmented matrix and RREF. Inverse method, I set up 2 matrices, and then A inverse times B will give me my answer. Okay, and anytime it doesn't come out nice and neat, math frac it so that you don't have to round it off. All right, you good on the calculator? Okay, now we can put them away, we don't need them now. Now we're gonna solve another system. This is a much smaller one. And you know I want to eliminate because that's what I like to do, but I can't eliminate. The directions say solve using Kramer's rule. So what's that process? I use determinants, exclusively determinants. And the first determinant I use is right here, the coefficients. Now, I'm not going to deliberately try to mess you up, but do pay attention that your x's and y's are lined up, and that's important. You have an x column and a y column. All right, what's the value of that determinant? 13. Now, what do I do with that 13? That 13 is the denominator of x and y. So x is going to be 4/13, and y is going to be 7/13, something like that. They're fractions. How do I find the numerators? Take these guys, copy and paste on whichever letter you're doing. So if you're doing x, you're going to copy and paste them on the x's. So you have 8, -7, and then -3, 5. If you're doing y, you're going to copy and paste here, so you have 2, 1, and 8, -7. So what's that one? What? 19. Very good. Thank you, Van. 40 minus 21. 19. So x is 19/13. How about y? -22. 13. That's -14 minus 8. Are you okay with that? That problems are going to be all about process, not about answer. I mean, the answer is going to matter, but most of the points are coming from the process. Find the area of this triangle. So you don't have to draw a picture of it, but you certainly can. Just to kind of keep straight what's what. All right, how do we start this one? We're going to find the area of this triangle. We don't have a calculator. So all of the things we learned before are going to be really hard to do without a calculator. You know, we're going to have side, sine, and all that stuff. So what do I do if I don't have a calculator to find this? Brayden? Find what we call the directed distances or the vectors. So if I pick C, I'll find vector CS and vector CH. And this is real simple. Just ask yourself, with X, I'm going from, when I go from C to S, I'm going from 1 to 4. Positive 3. Direction, distance. Positive, direction, 3. Negative 1 to 1. 2. Positive 2. Now, what about from C to H? 1 to 2 is 1. And negative 1 to 2 is 3. If you picked a different point, if you did HC and HS, for example, you're not going to get these numbers. But ultimately, your answer will be the same. All right, so what do I do now to get an answer? Make that a determinant, just like this. Don't change a thing. So 3, 2, 1, 3. So what's the value of that determinant? 9 minus 2, which is 7. And then remember to do what? Since it's a triangle, divide it by 2. So the area of the triangle is 7 halves. 3.5. 3.5. I don't care. Perfect. One more. What do you want to do with this guy? Not Kramer's rule, folks. Not Kramer's rule. See that? That messes everything up. So what do you want to do? So, I think I'll multiply the top row by 2. So I'll have 2x minus 2y equals 6. Does that look okay to everybody? Now when I add them, these cancel, but be careful. These don't add. So I'm going to have x squared plus 2x equals 3. See that? Quadratic. That one factors. Now where do we go from here? So the x's are negative 3 and 1. And now we go back maybe to that top equation and say, okay, if this is a negative 3, what does y have to be? Be careful. Negative 6. And if this is a 1, what does y have to be? Negative 2. Your answer to that question is going to be both of the points. All right, we'll finish that next time and I'll figure out when we're taking a test.